Hello everyone, Kodungane the Native God here. Welcome to part 2 of solving this problem. In part 1, we looked at this problem, solving it using the method of components. Now in this video, we are going to solve the very same problem, but using the parallelogram method, right? Now, with the parallelogram method, what we do is we look at, or the way we represent relative velocity is by taking the velocity of the object and drawing it up exactly as it's been given in the statement, whereas the frame of reference or the velocity of the frame of reference, we draw it in a direction that is opposite to the one that's been given in the statement. Now, what do I mean by this? Now, if you look at number 2a, it calculates the velocity and direction of A relative to B. So A is our object and B is the frame of reference. So A being the object, it means we are going to represent it on the Cartesian plane as it's been given in the statement. Now remember, this is relative velocity for objects in non-parallel lines. So we have to draw a Cartesian plane, right? And then draw up our vectors on the Cartesian plane, or represent the vectors that have been given on the Cartesian plane, right? Now, so again, in the parallel, or when using the parallelogram method, the velocity of the object or the direction thereof, we are going to draw exactly how it's been given in the statement. Now, for A, right? For A, our object is object A, right? And they said car A is moving due north at 70 kilometers per hour. So we're going to draw that exactly how it's been given in the statement, right? We are going to draw A exactly how it's been given in the statement, right? You said this is moving north, right? Right. Right. So you said VA is moving north and this is 70 kilometers per hour. So again, the velocity of the object or the direction thereof, you represent on the Cartesian plane exactly how it's been given in the statement. Whereas the velocity of the frame of reference, the frame of reference being B, we are going to show that on the Cartesian plane, right? Or we are going to represent the direction of curve B, which is the frame of reference, in a direction that is opposite to the one that's been given in the statement, right? Now in the statement, they said curve B is moving 6 degrees west of north, which essentially is the same as north 60 degrees west, right? So curve B being the frame of reference for 2A, right? We are going to represent in direction or in a direction that is opposite to the one that's been given in the statement. Now for this case, right, we look at the opposite of north, south, the angle remains the same. Opposite of west is east, right? So the way we are going to represent the frame of reference, which is B, right, is going to be in a direction south 60 degrees east, right? Now remember, when using the method of, or the parallelogram method, you have to make use of your protractors, right, in showing, or so that you are able to be accurate in drawing up your angles, right? Now, because of the app I'm using, I'm going to be using this ruler, right? The reference is south right? 60 degrees east, right? So adding 60 degrees here, we get 150, right? But when you are using your protractor, you should make south your reference, and then measure an angle of 60 degrees, right? So 60 is right there. So you would have something that looks like that, right? Right. So this is B. B is moving at 100 kilometers per hour, right? So now to complete our parallelogram, right? Remember, when using the method of parallelogram or the parallelogram method, you have to make sure that the vectors you've been given, or the way you draw your vectors, they must be such that they are moving away from the point at which they meet, right? And then to complete your parallelogram, we're going to have this vector, and we're going to have this vector, right? Remember, these two lines must be faint, right? And then this means that our velocity of A relative to B will be in this direction, right? So that will be the velocity of A relative to B, essentially, right? So this will be the velocity of A relative to B, right? Now, what I like to do is, once I have my parallelogram, or once I've completed my parallelogram, I simply just label it all around. So that's going to be A, that's B, that's C, that's D, right? And then you have to work out your angles which will be convenient for our calculations, right? And then, of course, depending on the, because if you look at the parallelogram, right? If you look at the parallelogram, you simply have two triangles, right? So in this case, you have triangle ABC and you have triangle ACD, right? So when you've completed your parallelogram, you'll always have two triangles. Now your triangles will either be right angle triangles, or they'll be triangles that are not right angled, right? Now if you're looking at right angle triangles, you can simply just use Pythagoras in solving your problem, right? But if your triangles are not right angle triangles, then we make use of the cos rule, or the use of the sine rule, right? Now if you remember from mathematics, the cos rule, right? The cos rule we use if the angle you've been given, or if the angle you have is such that it is an included angle, right? Now an included angle is one where you have an angle between two vectors of which we have the magnitude of, right? So that becomes an included angle. So meaning, if for instance we had an angle, if we had this angle, right? If we had that angle, because we know this vector as well as this vector, right? This vector is 70 kilometers per hour. This vector is 100 kilometers per hour. Because we know the two vectors, the angle between them, if we were given, or if we had that angle, it would then become what? An included angle. Hence, we'd use the cosine rule, right? Then the sine rule we use if we have an angle that is basically not an included angle, right? Right. Now let's look at calculating the values of A relative to B, right? So first let's work out our angles, or the angles that you've been given. Now we know that this angle, right, is what, 60 degrees. Right, this 60 degrees alternates with this angle, meaning you have 60 degrees there as well, right? And then of course in a parallelogram we know that the angles opposite each other are what, are congruent, meaning this angle is also 60 degrees, right? And then of course the sides opposite each other are also congruent, right? So we know that's equal to this, and this is equal to this vector, right? Right. Now that we've worked out our angles, we can now use the information we have to get information that we don't have, right? Now, because the angle we have is such that it is an included angle, it means we're going to use the cosine rule, right? With the cosine rule, we're going to elect one triangle. So let's say let's say in triangle, let's say ABC, right? So in triangle ABC, so we're gonna call this A, small letter A, call that small letter B, call this small letter C, right? So we are looking for B squared is equal to what? A squared plus C squared minus 2AC cos the included angle, which is B, right? So we have everything here except the small letter b, right? Which in this case is what? Is the velocity of A relative to B, essentially, right? So now we solve for B squared. So B squared is equal to A squared, which is equal to 100. So here we have the 100 squared plus C squared, which is 70 kilometers. So you have 70 squared minus 2 into A, which is 100, C, which is 70, cos B, which is 60 degrees, right? So B squared, now if you punch this in your calculators, we're going to get 7,900, right? So 7,900, and then because we're looking for B, we'll apply the square root of each side, right? So B is equal to what? 88,882 kilometers per hour, right? So we essentially have the velocity of A relative to B at this point, right? So now we need to calculate the direction, right? The direction of velocity of A relative to B. Now, what I like to do is I look at the velocity of the object initially. Initially, the velocity of the object A was headed north, right? So I'm gonna use, for my direction, I'm gonna use north as my reference, right? So meaning the angle I'll be calculating, since north is my reference, it means I'll be looking for this angle, right? So still in triangle ABC, right? Still using the triangle ABC, I'm now going to calculate angle A, right? Using what? Using the sine rule, right? So sine A essentially, right, over, so sine A over the 70 kilonewtons, kilometers per hour. So sine A over, what is this? So over 100, right? So sine A over the 100 is going to be equal to what? the angle that you have, which is sine 60. So sine 60 over, right, so over the small b, which is 88,882, right? Then solving for sine a, right, we're going to multiply by 100 on either side, so we're going to end up with sine a is equal to 100 sine 60 over what? Over the 88,882, right? And then because we want the angle A will be equal to what? Arc sine of 100 sine 60 over 88,882, right? And angle A is going to be equal to what? Now if you punch this in your calculators, we are going to get 76,996 degrees, right? Therefore this means the rest of A relative to B is equal to what? It's actually equal to the 88,882 kilometers per hour, right? Remember the reference which I'm using is north, so it means this is going north. The angle is 76,996 degrees east, right? And this becomes the value of A relative to B. Now if you used east as your reference, right, it would mean you would have to calculate this angle, right? And that angle, right, if you calculated that angle, right, it would mean that you would have, or it would mean you got, so if we say 90 minus the 76,996, now if you calculated that angle, then it means you got 13 degrees, 004, right, which is fine as well, right? So your references regarding the angle doesn't really matter, right? You can either use the y as your reference or the x is as your frame of reference, right? Right. Now let's look at 2b using the what? The method of, or the parallelogram method, right? So now we are going to look at b using the parallelogram method, right? Using b. Now for b, they said calculate the velocity and direction of b relative to a. So b is now the object, and a is the what? Is the frame of reference. Meaning what? Regarding our parallelogram method, it means we are now going to represent the velocity of b as it's been stated in the statement, right? And then because a is now our frame of reference, we are going to represent the direction of a in a direction opposite to the one that's been given in the statement, right? So let's draw up our Cartesian plane. So this becomes our Cartesian plane, right? This becomes our Cartesian plane, right? So that's our Cartesian plane, right? Right. Now remember, B is now the object, and A is the frame of reference. Now B being the object, we are going to draw up in a direction that is exactly how it's been given in the statement, right? In the statement they said B is moving north 60 degrees west, right? So north is our reference, right? North is the reference. And then they said north 60 degrees west, right? So north 60 degrees west, right? We have to draw up b, which is 100 kilometers per hour, right? So again, remember to use your protractors for this, since we are doing the method of parallelogram, or the parallelogram method, right? So here we are going to have, right, so I'm going to measure 150, right? So that's 90 plus 30 degrees, and that is where we'll have the vector for object P, right? It goes up to that point, right? So we have this vector, it goes up to that point, right? Remember, they said it's north 60 degrees west. So north, the 60 degrees is right there. So we have 60 degrees here, right? And that becomes our VB, right? So VP is 100 kilometers per hour, right? And then, because A is our frame of reference, right? A in the statement they say is true north, but because it's our frame of reference in this case, we're going to draw it as if it's going south, right? Remember, for the parallelogram method, your frame of reference must always be represented in a direction that is opposite to the one that's been given in the statement, right? Right. So this, right. So this is in a direction, right? In the statement they said it's going north, but because it's the frame of reference, we are going to draw it going south, right? Right. Right. And then we have, there we have the 70 kilometers per hour. 70 kilometers per hour, right? And then now we have to complete our parallelogram, right? Completing our parallelogram, so we have this vector there, and then we have this vector to complete the parallelogram, right? Right. And then our parallelogram is complete. So meaning what? So meaning the velocity of P relative to A will be in that direction. So it will be this one here. So essentially this is the velocity of P relative to A, right? So now we have to calculate the magnitude as well as the direction of velocity of P relative to A, right? Now we know that 60 degrees, this 60 degrees, right? This 60 degrees is alternating with this angle, so meaning that's 60 degrees as well, right? Now we can label our triangle, right? So like I said, when using the parallelogram method, I always like to label the parallelogram once it's complete. So you have A here, B, C, and you can call it D, right? So again, the angle we have is the included angle, so we can use the cosine rule, right? We can use the cosine rule using the triangle ABC, right? So let's say in triangle ABC, right? Now that will be A, that's B, and that's C, right? We are looking for, so B squared is equal to what? A squared plus C squared minus 2AC cos B, right? So B squared is equal to, A is equal to 70 kilometers, so 70 squared plus the 100 squared minus 270 into 100 cos, and angle B is 60 degrees, right? Now if you punch this in your calculators, you're going to get 7,900. Because we're looking for B, apply the square root for both sides, and B, if you punch this in your calculators, you're gonna get this 88,882 kilometers per hour, right? Which, if you look at the velocity of A relative to B, was the same in magnitude, right? So the actual velocity for this object is actually 88,882 kilometers per hour, right? And this confirms it, right? So we essentially have calculated the velocity of B relative to A. Remember, the relative velocity will always be the resultant of the what? Of the parallelogram, right? So now we can calculate the direction, right? Now B, they said B was north 60 degrees west, right? So because we used the y-axis as our, what you might call it, because we used the x-axis, the y-axis as our reference for 2a, we're going to use the x-axis as what? As a reference for 2b, right? So meaning we are going to calculate this angle, right? We are going to calculate this angle. So still using triangle ABC, we are now going to calculate that angle, right? So in calculating that angle, we first need to get this angle here, right? So still using triangle ABC, we are going to calculate this angle, so angle A, essentially using what? Using the sine rule, right? So sine A over A, which is 70, so over 70 is equal to, so sine 60 over, so sine 60 over the velocity of P relative to A, so the 88,882, right? Then we multiply by 70 on both sides, and you are left with sine A is equal to the 70 sine 60 over the 88,882, right? And to get the angle A, we are going to calculate the arc sine of 70 sine 60 over the 88,882. Right, so now if you punch that in your calculators, you're going to get the angle A as being equal to 43,004 degrees, right? So the angle A is the 43,004 degrees, right? So to get the small angle, which is referred from the x-axis to the velocity of B relative to A, right? It means since we know that if this angle is what? If this angle is 60 degrees, it means this angle is what? 30 degrees, right? So to get this angle here. So to get this angle, it means, let's call this angle theta, right? Let's call that theta. So to get theta, theta means is equal to what? The 43,004 minus the 30 degrees, which will then be equal to 13,004 degrees, right? Therefore, the velocity of B relative to A is equal to 88,882 kilometers per hour, right? Remember, the x-axis our is our reference, right? So the x-axis being west, it means this is west 13,004 degrees south. Yes. So if we're using the x-axis or west as our reference, then our velocity of B relative to A is equal to 88,882 kilometers per hour, west 13,004 degrees south, right? And that's the approach we would take, right, when using the parallelogram method, right? So I hope you found this helpful. You can stay tuned for more videos like this, right? So don't forget to like and subscribe to the channel, because I'll be posting more content based on engineering science and 4, right? Thank you.